Yeah, thank you. It's really amazing to be here. It's really a treat. And actually, as I was preparing this seminar and I met some of you yesterday, I started thinking about my first days in physics. And when I switched to physics, I used to be an engineer before. I actually moved to Berlin in Germany. And it was different times. It was over 15 years ago. Berlin was still a dark, edgy city. It was extremely cheap. I lived really a good life with a salary of a PhD student, probably better than the one I'm leading now in New York. So it was still, the times where East Berlin was communist Berlin. I mean, it wasn't communist Berlin, but still had that vibe. There was a big difference between the two parts. And so I moved there. I was really excited to start in physics. I was also really scared by physics. I was scared by the new country, by the new language. And I just thought of an episode that happened maybe about a year after I moved there. And I was basically spending days and nights working on my PhD. I only had two friends, two fellow PhD students. And we really were eager to connect to Berliners, to connect to Germans, to start speaking the language we were desperately trying to learn. We went to a party one night. It was a tremendously cool party. We were eager to make new friends. And the party was in a military bunker in the Spree, the river that separates East and West Berlin. And we went there. There were a bunch of musicians throwing this party. And we were there sort of a little lost, and we're just hanging out among the three of us. And at some point, we were speaking Spanish, and some Germans approached us, and we're really very happy to make their acquaintance, to make new friends. And they could speak a little Spanish too, and so they started asking us questions. They were curious about what we were doing in our lives. And so they asked me, he said, what are you doing? And I answered, I'm doing a PhD in physics. Oh, that's interesting, they said. What about? So it's about a femtochemistry study of acid-base neutralization reactions in water. They weren't too excited about my answer, so they turned to the second of us and they asked him, what are you doing? And he replied, I'm actually doing a PhD in physics on the use of network theory to study the spreading of infectious diseases. It's actually pretty cool stuff, thinking about COVID and the like, but it did sound a little technical. So these guys were a little desperate, and they turned to the third person and they asked her, what are you doing? And she said, well, I'm using the theory of nonlinearly coupled oscillators to study El Nino-like phenomena in climate. She was doing really cool stuff on climate change, but the way that we were giving our answers was definitely not appropriate for the audience. The guys approaching us were musicians, and they didn't seem to be particularly interested, because not just because our topics were not interesting, but because we presented them in a way that was absurdly technical. And I think this is an example of the challenges that we have sometimes in physics. How can we communicate physics to other people and to an audience that is not necessarily as knowledgeable as we are about that particular topic? Of course, that was an extreme case. We're talking to people who had no background in science. But I do think that in physics, there is a little bit this problem. Physics is complicated. It requires a lot of math. It requires a lot of background. And sometimes we don't think carefully enough about how we communicate it, how we translate it into words, how we understand who is our audience and relate to the audience so that they can appreciate what we're talking about. So this is a little bit what I'm going to talk about today. The topic is writing scientific papers, so I will focus on the writing aspects. But I do think that the principles that we're going to talk about are really much broader than this. They apply to a talk, and I think they can apply to a simple conversation that we're going to have with a person that we meet on the street, and we want to talk about physics with them and make sure that they can follow. Let me start, and I think I want to give two concepts in this talk. The first one is to try to recognize who your audience is, who are you really speaking to, and then to find the best way to relate to that audience in a way that's engaging for them, and so you're not excluding them from the conversation. And I like to start with the take-home message of this talk. So if you just fall asleep after the first slide, or need to do something else, or need to go back to solving your problems, you can do that. I think this is really the one message that I like to leave you with. And I hope this message will be reinforced by the things that we're going to talk about today. If you are a scientist, no matter what kind of scientist, if you are an engineer, if you are a physicist, be in academia or in the private sector, if you are a scientist, you are a professional writer and a professional communicator. Maybe that's a little broader than writer. So if you're doing science, it's really important that you convey to others the meaning, the beauty, the importance of what you're doing, the potential impact, because that's the only way that your science, that your work will matter. And I think communication often is sort of neglected in many of our settings, certainly in the physics departments. They teach you how to code in a language, they teach you a physical theory, they teach you some mathematical tools, but very few people have the chance to spend some time thinking about their communication skills. So my argument today is that communication is an integral part of your profession, and you should treat it as professionally as you do with other aspects of your studies. So if you are taking a class to learn particular aspects of physics that's essential to your research, you should also think about communication. I'm not arguing for taking classes, doing workshops necessarily. They can be very useful, but the most important thing is that you just take on this responsibility. You are a communicator, you are a writer, you are a speaker. So every time you're doing that, every time you're talking, every time you're speaking, every time you're writing, use it as a chance to grow in that compartment, use it as a chance to train and take up that challenge really professionally. And if you do that consistently, you will improve and you will benefit it in many, many possible ways, not necessarily just for doing an academic research in physics. So I just like to give you a little bit of background about what I did in the past, so you have an idea of where I come from. I used to be a scientist. I used to be really a hardcore physicist, and this is essentially the experiment that I was doing. This is an experiment done about a century ago, stroboscopic photography. It's one of the first examples of this technique. And the purpose of that experiment that they were doing was actually to study how a horse runs, how it's galloping. Is it flying with the legs off the ground, or do the legs always touch the ground? People didn't know. It's when a horse is galloping, it's too fast for your human eye. You have a resolution of 25 milliseconds. You cannot see that. So this photographer, Muybridge, is both a very technical person, but he's famous as an artist. He took the sequence of pictures and they could settle. If you see in one of the panels, the horse is indeed flying at some point. You see here. So he settled that question. Of course, I was working in the 21st century, so we're not really interested in horses anymore, not scientifically at least. And I was doing basically the same thing with lasers. So instead of using a camera where you just take pictures and you open and close a mechanical shutter, I was using laser pulses. And this laser pulses take snapshots of your sample. And basically what we were doing, we were trying to build a very, very fast camera to observe processes in the microscopic world. So the one thing that we were particularly interested in was chemical reactions. How fast do they occur? How do molecules move when they are undergoing a reaction? So this was the focus of my research. And I think the most important thing I was a pretty lucky scientist in terms of publication. These are some of the issues of the journals where I published. So, you know, lucky, I was probably decently good, but one thing, I was really good at writing papers, and I think that played a role. And the most important thing I did was a study of how protons are transferred in water. That was really the first time that people could film this chemical reaction so directly. And we could measure the time of proton transfer in water. It's an essential chemical reaction for chemistry, for biology. It was a big headline. It was picked up by some newspapers too. And so everybody was expecting me to actually stay in science and to become a professor somewhere. But at some point, I had an experience that really changed my path. And for a summer, I moved to a political body, the European Commission. And I was working there. I was doing an internship. And I was working really with politicians. They are mostly lawyers or professional politicians of different nature. And I was helping them trying to design their policies so that they would be science-based. I think the major things that we were doing were related to giving money to research. And so we were managing a budget with over 20 billions of euros. So it's pretty huge. And these politicians had to decide what kind of projects should they fund. We were particularly interested in climate change and renewable energies. This was sort of my field when I was there. It was a very interesting experience. And obviously, as you can imagine, it was a very interesting communication experience, because you're talking to people who know really nothing about science and technology. And my approach in the beginning, I had a little bit of a feeling of superiority. I thought, oh, we scientists, we know what we're doing, we know what's important. And they are just stupid. They just don't get it. And it's their fault if they don't get it. But very quickly, I realized that a lot of the problems were actually coming from the scientists' side. I was preparing scientists to meet with politicians. And I remember one day we had this big meeting where a scientist came to argue for more funding for nuclear physics in Europe. And he had 10 minutes to speak, or 5 minutes to speak to the European Parliament about that. And in 5 minutes, he managed to say 3 times quadrupolar moment. And you can imagine, how can a politician possibly know what is a quadrupolar moment? As a scientist, I would have to think about it. So that sort of clarified that there was a challenge there, and there were a lot of problems not on the politician sides. They actually knew more science, and they were ready to hear about science. They were eager to connect to us. There were a lot of problems from our side, from our physicists, from our scientists' side. We could not communicate enough. We could not communicate sufficiently well with them so that they could understand us. And there was this thing that really disturbed me, that the consequence of this was that they saw us as really something strange. And I think the images that you find in the media about physicists do correspond to the image that we are sort of conveying to them when we are speaking in a way that's too technical. So that's how scientists are portrayed in the media. They're old white men, somehow dangerous, and they have one thing in common. They really do not talk like normal people. The way they communicate is really very technical and inaccessible. And so I think that's the way I felt that these important politicians were seeing when they were looking at me. And I know that we physicists, we're not like this. We are normal people. We are doing beautiful research into the mechanisms, that nature uses. And we're doing very important stuff that is going to change technology, that's going to have a profound effect on the economy. So I decided to dedicate the rest of my career, instead of doing science, to dedicate it to communicating science. And that's what I've been doing ever since. And so I like to try to give you a number of further motivations for writing and communicating well. And a lot of times, especially when I talk to young people like you, the only thing that people have in mind I guess maybe more for PhD students, they think that if they write well, they're gonna publish a lot. And that's the only thing they have in mind. But I would argue that there are so many reasons to try to communicate well. Getting published is only the first, and probably it's not going to be impacted, because when you're sending a paper to a journal, the people who are looking at the paper, they are experts in the field, they know already your field. So they will, even if you don't write it very well, they will get the message. But other important aspects include getting cited. So your paper is out there, people are going to read it, and they're only going to cite it if they understand what you're saying, if they understand how it connects to their own work. And so you have to really think about who is going to read your paper actually, who is your real audience. And I can tell you that the most highly cited papers are always the best written ones. And today, in today's world, if you stay in academia in particular, citations is the #1 measure of how good of a scientist you are. So that's an important aspect. Another aspect is to getting proposals funded. If you go on with your career, no matter whether you're in science or in industry, you need to get money for what you want to do. And in many cases, the agencies who are funding research, they administer a huge portfolio of projects. So you have to send a proposal for them so that they give you money. These proposals have to be masterpieces of communication. And you really have to understand who is going to read your proposal. They are people, they are scientists, they are people who know technology, but they are not experts in your field. So you have really to get your message across to them. Another important aspect is communicating with scientists from other fields. And, you know, there is a drive, science is becoming more and more specialized. And we work on a really narrow topic for decades, for our entire careers. However, I would say that many of the breakthroughs that will happen in science, in physics in particular, will come from interdisciplinary research. You'll see people studying solids, merging with people studying cosmology and astrophysics, and using each other's idea to solve problems in their fields with input from other fields. And this is only possible if physicists and if scientists are able to communicate across the barriers of disciplines. So that's another very important reason to become a good communicator. Another reason is the fact that communication skills are actually useful anywhere you go. I teach at NYU University in New York, and these people do not know whether they're going to be academic researchers for the rest of their lives. Actually, most of them will go to work for Google, for Facebook, for a high-tech company. And one of the things I learned is that communication skills are one of the most transferable and appreciated skills that a person can have. So even if you're focused on research right now, even if you're focused on physics, but you're uncertain, you don't know, maybe you want to do something completely different. If you work on your communication skills right now, you will learn something that it will be useful to you no matter where you go. And finally, many of us do science because maybe they are not too good in the humanities, maybe they don't like writing too much. I do think that if you work on it, if you get better at it, if you hone your skills, if you become better, you will start having more and more fun with it. And I am an example of this. I really didn't like it when I started. It was such a painful act to sit down and write a paper. But then I worked on it, and now today, writing is actually my profession. So the more you do it, the more fun you'll have. And instead of becoming a duty, it will become a fun activity. So those are, some of the reasons. And let me talk to you briefly about what I am doing. I am the editor of this magazine, Physics. You can find it at the address here. Here, we're trying to communicate really to people like you, a broad audience of people who do not have actually a PhD. And we're trying to communicate the biggest results in physics, in contemporary physics, to them in a way that is accessible to them. I have to say it is not always possible. Some of our writers are not skilled enough. So some of these articles might be a little technical, but that's the goal that we have, really communicate in a very broadly accessible way. We don't want to communicate to, to your grandmother and your parents. We do want to communicate to scientists, no matter what their level of experience, no matter what their field. And some of the things we do is we ask other scientists to write for us about the biggest discoveries. And I'll give you a few examples. This was in 2016, the discovery of gravitational waves. We published that paper. So what happened is I write to a scientist and I ask him, can you write a commentary about that paper? And that commentary has to be accessible. So I sit down and I work together with the scientist. So I help him or her produce an article that's accessible. This is another example. One of the latest papers by Stephen Hawking was published with us. He was commenting on this famous black hole paradox, very complicated physics, and we were trying to explain it in a very accessible way. We're also trying very new ways of communicating physics, and this is a wonderful cartoon that we had. You might have heard this year about this experiment called G-2. It is basically showing that we need new theories for the world. And it was a big news. It was in all major newspapers in every country. And we hired a famous cartoonist. His name is PhD Comics, or Jorge Cham. And he rendered this very complicated thing in a very simple cartoon. I think you should definitely look at this. It's a lot of fun. It explains, it shows to you how a physics story is actually a very compelling story with a very engaging narrative. And there's always something like this behind every physics result. And also I'm doing some other crazier things. This is a dance show inspired by chemistry or physical chemistry. It's about why we remember the food that we ate. So we're trying to communicate physics to a number of means, using art, using visuals. But of course, written articles are our main form of communication. So I'm bringing these things up, and I want to discuss two aspects that are very important for my work. First, I have to find the best science, and second, once I found it, I have to communicate it. So how to find the best science? I estimate that I've read more than 10,000 papers in the last 8 years or so since I changed to this profession. So I became a very efficient reader. And I can tell you what I want to learn from a paper. I want to hear about the motivation. Why was this research done? What is the holy grail? What is the, if you could solve a big problem, what would that problem be? The second is, what is the more specific question that you're trying to answer? So maybe the holy grail is to develop alternative energy technologies. Of course, you're not doing that with your paper alone, but maybe there is a more specific need. Maybe you're working on solar cells, and a particular type of solar cells gets degraded quickly if it's exposed to the environment. So what are the specific needs, the specific questions that you are going to answer in that paper? A third question that I want to know when I read a paper is, what is really new? What is the one new thing that you're presenting with this paper? And I can tell you sometimes it's really hard. You don't understand what was done before and what is new in the new paper. And if I want to highlight a paper, if I want to communicate it, I really need to understand what is the new thing? What is the one thing that is worth its publication? What's the new piece of knowledge that mankind should receive from this paper? And finally, and that is a very lacking element in many papers that I read, what are the implications of the result? A lot of people tell, oh, I did this beautiful experiment and here's the results. And then I ask myself, so what? Why should I care? What happens now? And a lot of people forget, because for them, they already know that the implication of measuring something, the implication of developing a theory, they know what they are, but your readers will not know. And so it's very important that you tell them. So a good paper really answers these 4 questions, always. And the other thing that's relevant for this talk is the fact that as I said, I work with scientists and I help them write. So I've edited hundreds of scientists. I think the youngest are postdocs. Maybe once we had a PhD student, and the most experienced, I edited a couple of Nobel Prize winners, and, very, very big scientists. So really all levels, all fields. It's a complicated process because some of them can write, some of them do not write very well, some of them have big egos, they're divas and they don't want to be corrected. Sometimes it's easy, sometimes it's hard. And a few times, these are not very common responses, but these are some of the emails that I receive from them when I propose my edits, my changes to their articles. The first is writing, "You're simplifying too much. They will think I am stupid." The second writes, "If a scientist does not know what a Lyapunov coefficient is," and I had no idea, "he and you should just go back to school. I'm not going to waste time explaining it." And the third is a theorist who writes, "You have massacred my text once again. There is no way to explain this without Hamiltonian equations." So I think this kind of responses are good examples of the challenges that we have in physics when we're trying to communicate. The first one thinks that being simple means being stupid. The second cannot imagine that people do not know what this very technical word, Lyapunov coefficient, means. And the third only thinks about physics through his equations. These are the things that he's using. So these are the challenges that I think derive from the environment in which you're working, the environment of physics department. I think the first one is that these environments lead us to talk always to our supervisors, competitors, and colleagues. So we give our seminars to our supervisor. We give our seminar to our group. So we're talking to people who already know. We use jargon because they will know it. We use technical words. Also, we're talking to impress them. We want our supervisor to think, hey, this guy's done a good job. He's evaluating us. We're also spending a lot of time communicating the how. How did we do the experiment? How many hours do we spend in the lab? What problems did we have to solve? The second challenge is what I call the curse of knowledge. And if we go back to those emails, certainly that's a challenge in the second one. The curse of knowledge is the fact that you spend so many years working on something that you simply forgot how it was before you knew all the things that you've learned in the process. So you cannot possibly relate to somebody who does not know all the words, all the physics that you know. So this is something that we really have to fight. And finally, the last challenge is not relating to the audience. So these people are not really clear about who is going to read the article. If you write for a high impact factor journal, if you're giving a talk to a conference where there are many people, your audience is actually very broad. And so you really have to think about who they are and who you're speaking to, and forget that you're just talking to your supervisor, because that's not the case. There will be many more people there, many more people reading your paper. So you really have to understand who your audience is. So how to overcome these challenges? The first is really think about who is the reader of your articles, who is the audience. You're talking to people, you're talking to somebody like, us, 3 PhD students in a party in Berlin, we're talking to 3 musicians. Who is the audience there? What words can we use? What concepts can we use? The second thing that I really support is the fact that you can learn to be a good writer. You can learn to be a good speaker. A lot of people think, oh, you're bored. You have a natural talent for writing. You wake up in the morning and you can write. You wake up in the morning and you go out and give a brilliant talk. That's absolutely not true. All the good writers that you meet, all the good speakers that you meet, they are like that because they spend a lot of time, because they focus their thought on that practice. So do practice and you get better. And finally, if you want to write well, read a lot. And that's really a recommendation that I have to you specifically at this stage of your career. You have to decide what to do next. You have to decide, what your career is going to look like. Try to read everything. Read many papers. Read Science and Nature. Read science journalism. Try to really be exposed to as many ideas as you can. Scientifically, you will learn about many things that you may want to pursue. But also from the point of view of communication, when you read something and it's expressed in a nice way, try to learn from what you're reading. And obviously, all the best writers, fiction writers, I'm talking about literature, they are the best writers because they have read everything that was published before them. So you will learn to write well only if you read a lot. And I also like to, an audience like this, to emphasize this. There is zero correlation between speaking English well and writing well. Of course, if you're not a proficient speaker, you will make mistakes. Grammar will not be all right. But writing is not really about grammar. When I started my job as an editor, I thought when I received a draft article from a scientist in the UK or US, I knew they were a native speaker, and I thought, oh, this is going to be easy. English is their native language. I'm just gonna fix a couple of things. It's gonna be all right. Instead, when I was receiving a paper maybe from my own country, from Italy, I was nervous. I thought, oh my God, I'm gonna have to rewrite everything. Very, very quickly, I realized that there was no correlation. Writing is not about not making mistakes. Writing is not about writing science in particular. It's not about rhetoric and literature. It's about clarity of thought. It's about logical sequence. It's about explaining clearly what you want to say. It's about knowing who your audience is. So even if you're not native speakers, you can write extremely well. The editors will correct your grammar mistakes, or you can hire a company, or you can ask a friend. There are many ways for doing this, but really the good writing doesn't come from speaking well. So in the next 15 minutes, I'd like to discuss quite briefly a more technical, maybe part of my talk. It talks about how you should approach writing and different stages of writing that I actually follow when I work with a scientist. And then I will conclude with some more philosophical notes about communication. So this is how I usually approach writing. So a scientist sends me a draft, and the first question I have is, what is the story that you want to tell? And I really would like to emphasize that when you're writing science, you're telling a story. What does a story mean? It means you have to communicate these 4 questions that I talked about before. Why did you embark in that research? What is the Holy Grail? What specific questions do you want to answer? What you need to answer that question? And then why should we care? So the story is really a narrative that should encompass all these elements. So I really believe that writing is storytelling. And before you even start writing, actually, you should brainstorm. And a lot of people start writing, they put down their ideas, but they really don't know what's their story. And so sit down before you start writing, brainstorm, and the more time you'll spend on that without writing, really just thinking about what your message is going to be, the faster the writing will be. Also, telling a story is more than presenting results. Of course, you've done 1,000 experiments, maybe you've done 1,000 calculations, but not all of them may be necessary. So telling a story is just choosing the results that serve you to tell the story. So if you have your story very clear, you can also pick the results in experiment that are necessary to tell your story. And I like especially to contrast, because one of the most common mistakes or shortcomings in papers that I read is that they just tell me what they've done. They describe a long sequence of experiments, and I have no idea why they did them, and I have no idea about the so what. Why should I care? So I really like to contrast telling a story with presenting data. And these are 2 extreme examples of 2 papers. They're very famous papers about DNA. This first paper by Rosalind Franklin shows the X-ray pattern that you observe if you shine some X-ray light on DNA. This is presenting data. You're showing a pattern that you measure. So it's really data, it's not a story. What's the story behind this data? The story behind the data is that DNA has a helical structure. And so this paper by Watson and Crick tells the story. It tells you that based on those data that we serve, we can conclude that DNA is helical, and this has many implications for biology, all the copying mechanisms for genetic processes and so on and so forth. So perhaps, maybe I'm a little exaggerating, but perhaps the fact that Watson and Crick were credited for the discovery of DNA with the Nobel Prize, while Rosalind Franklin wasn't, is the fact that they were the ones to tell the stories, and she was the one who presented the data. This is, there are many other reasons. There were other times. I think the fact that she was a woman maybe played a role back then, unfortunately. I think today we are in a much better, although not ideal condition, but things have improved in that sense. But this is an extreme example to explain to you what's the difference between presenting data and telling a story. Also, one thing that I really believe in is that every paper tells one story. A lot of scientists come to me and they want our journals to publish their paper. And they tell me, oh, there are so many reasons for publishing this paper. First, we measure this. And second, we achieve the highest efficiency of this kind of devices. And third, this is also important at the fundamental level. And fourth, so the additive property does not apply to a paper. You should focus your writing, your communication. If you give a talk, your message has to be focused on one story. You want the reader, you want the listener to go home with a clear message very firmly planted in their heads. So try to understand what is the one story that you want to focus on, and try to build your talk, your communication, your paper so that it tells that one particular story. And one thing that I really recommend is to summarize your story before, when you're writing, with 2 lines. These are some examples. 1 line. Let's take the last one. A good memory for light. A solid state optical memory stores a light pulse and even a full image for more than 1 minute, the longest light storage time reported in any system today. So you see, a sentence like this tells the gist of the story. What is new in this paper? It's a solid, and you can store an image into that solid and then retrieve it after a minute. So it has to be this short and this level of clarity. Try to have that little summary ready whenever you are giving a talk, whenever you are writing a paper. It will guide your discussion, will guide everything that you're doing after that. Sometimes you don't have that story. You start writing and the story emerges in the process of writing. So it can also happen that the story comes up later. But once things are ready, you really have to ask yourself, do I have that one story very clearly communicated there? The second stage, once we have that story clear, is to build a story structure. And that's really about being logical, about following a logical sequence. And you'll be amazed at how poorly structured many papers are. And one of the suggestions is that to use a logic flow diagram. So when you design your paper, follow a very logical structure. And that, if you remember those 4 questions that I talked about before, I think this is the structure that will apply to most papers, the classical structure for a scientific paper. First, you're giving the context, the broad why, the holy grail, the dream that you want to achieve. Second, the research needs, the more specific why, the specific problem that you're trying to solve. Third, what you actually did, what kind of experiments, what kind of measurements, that's really the core, the more technical part of your paper. And fourth, the implication, the so what. I did this, what happens now? Why should you care? Why would future research be impacted by what I've done? So this is a structure, I think, that works for most papers. Maybe some exceptions, but I do recommend that you have this structure in mind and think about, even if you're giving a talk, are you communicating these 4 points or not? That's really important. So in a well-written paper, you can really see that structure, the context, the specific needs, the detailed core of the paper. And a very useful tool is to use an outline when you're writing. So have an index like this on the that clearly breaks down the logical flow, and it will help you see, are there any logical steps? Is there any repetition? Maybe there's a paragraph that says the same thing twice in the paper. So if you follow this, you will realize that your paper will be extremely well organized. Very briefly, a very important element of your structure is the paragraph. The paragraph is sort of the atom of the logical unit of your paper, right? The paragraph should be, according to this famous teacher's writing, the unit of composition. What do I mean by that? So every paragraph should tell a little story by itself. And that story should be encapsulated in a focal sentence. So when you read a paragraph, what is that one message that that paragraph is giving? And there are two important options for placing that focal sentence: at the beginning or at the end of the paragraph. And let me just give you two examples. We will not have time to just understand what these paragraphs are about, but this is a paragraph that says, it's a paragraph from that discovery of gravitational waves. It says the basic features of this number, this is the event, how they call it, that signal that they measure, pointed to being produced by the coalescence of two black holes. So the two black holes swallowing each other. The features of the data shows or suggests that this is what produced the signal. So the paragraph starts with this focal sentence, and then you read the rest, and the rest of the paragraph explains, basically gives argument for that conclusion, for that focal sentence. So you give the reader the main message, and then you explain that message in more detail. And another option is to use a focal sentence at the end of the paragraph. So maybe the beginning of the paragraph describes a number of experiments or a number of calculations, and then there is a sentence that wraps it up. And this way of writing paragraphs is very, very useful. And I suggest you maybe look at one example. This is an incredible paper. They're using lasers to discover Mayan ruins in Guatemala. And it's written in a perfect way. And they make an incredible use of paragraphs. And if you look at them, every paragraph starts with a focal sentence. And you can actually, instead of reading the whole paper, you can start by reading the first sentence of all paragraphs, and you will get the story of the paper. You will get a clear message. And so you can sort of look at the paper from above and from an aerial view, like with a drone, and you can see the focal sentences. You can see the structure of the paper. This also allows for what I call non-linear reading. You have that paper, maybe it's something that you have to refer to many times. It's a paper that's important for your research. You go back to it and you can read it non-linearly. You can just pick the paragraphs that really matter to you. You see that focal sentence, you go back to them, and you can skip all the rest that's not important to you in that specific moment. And the last stage, you found your story, you design a story structure, then you have to find the best language for the story. And there are many things that you should do. I will give you some resources at the end, but basically apply effective writing strategies. I recommend that you download, especially if you're really going into physics. This is the appendix of an article, a review of modern physics. It's called Writing a Better Scientific Article. It's really a very detailed guide that gives you some of those writing techniques. Things really about adverbs, subject verbs, common errors, common grammar errors of non-native speakers. It's really a useful resource. And let me point out some examples. And I think that the main one is regards economy and lightness. So the first refers to what I was talking about before. We are not just talking to our supervisor. We don't have to speak and write in a complex way for an audience that's made of people who are judging us. We want to communicate with them, not to be judged by them. So don't try to be complicated. There is no need to be complicated. That person who wrote, this is too simple, I'm going to look stupid. That was absolutely not true. The simplest you can be, the best it can be for you. Of course, you want to be accurate. You want to, you don't want to simplify things so that it's so vague that you don't convey any message, but try to be simple and try to be as quick as possible. This is another great book on writing. And he says the secret of good writing is to strip every sentence to its cleanest components. The secret of good writing is really to cut all the clutter, every word that serves no function, every long word that could be short, every adverb that doesn't need to be there. Many things that make the paper longer than it should be, they are detrimental to the paper. And I'm just giving you some examples. This is a typical sentence that you encounter in the conclusion of a paper. This work sheds new light on the physics of nuclear fusion. So you're reading this in the conclusion section. What is it telling you? This work sheds new light, tells you something new on the physics of nuclear fusion. By the time you read that sentence, you already know the paper probably is about nuclear fusion, I guess. And what does sheds new light mean? Obviously, it's a paper, it's been published. It's going to tell you something new. So basically, this sentence is telling you, oh, this work is actually telling you something new about the subject that you already know we're talking about. So it's a useless sentence. There are sentences like this, you can just cut them, your paper won't suffer. Adverbs are often not very necessary, so you really have to think about them. A lot of people write, oh, this is very high. What's the difference between high and very high? Do you really need that very? A colleague of mine, I mean, a Nature editor, once told me that she was going to replace automatically in every word file she received very with bloody, which is of course a curse word. And then she'd go through the paper and all the very would be, this number is bloody high, this experiment is bloody important. And obviously she would delete all the bloody. And she said the paper would never change. So all this very were really not needed. Jargon, do you really need to use jargon? I am looking at a lot of papers these days that are studying how birds migrate in the magnetic field of Earth. But these people, they can't say birds. They need to say the avian species. Why? Because it sounds more academic. It sounds more scientific. It sounds more complex and sounds higher. My argument is that if you can say bird instead of avian species, you should always choose bird. There is really no reason for using 3 words instead of 1. There is really no reason for trying to sound more complicated than it is. When I read it the first time, I was actually curious, is there any difference between the avian species and birds? You know, maybe are penguin avian species? I really had to look it up. It's even confusing. But no, the avian species is birds and birds are the avian species. So use the simpler possible words that you can use, and that would be a big thing for your writing. I'll talk about this later, the use of active versus passive. Another suggestion is to use the shortest possible sentences. If you read this sentence, techniques for the direct phase modulation of laser diodes, typically based on the control of the applied current of voltage and always associated with a very dramatic amplitude and frequency modulation of the emitted light, have been available for decades while being insufficiently reliable for high bit rate communications and quantum key distribution. I cannot breathe. And it's not just a matter of style. It's really very hard. When I read this, I have to go back to it many times to understand the logical connections between the different parts of the sentence. So break it up into multiple sentences. And there are many ways of doing this. This just, you know, if you want to look at my slides and see how I did it, but if you read this, techniques for modulating the phase of laser diodes have been available for decades. They're typically based on the control of the applied current voltage. However, so on and so forth. You see how much clearer this is. You may not know anything about lasers, but you can sort of guess the logical concepts that this sentence is now communicating. Whereas in the first one, it was almost impossible to get them, even if you knew about lasers. And if you go to the resources that gave you that paper, you're going to see a lot of examples, complicated, clunky phrases that can be substituted by something that's actually shorter. And also, I'd like to spend some words on the need to depersonalize science. A lot of times when you read papers, they really feel very impersonal. And there is this push, which I don't think is good for science, to depersonalize. And the first thing is, can we say we and I? A lot of people don't like this. I guess scientists are a shy bunch of people. They don't want to be seen as boasting. So people don't like today to use we and I. They mostly use passive voice. A lot of times they can't say we measure this. They say it has been measured. Passive voice is longer. It is less engaging, less active. And also it can be very ambiguous. It has been measured. By whom? Did you measure it in your work? Did somebody else previously measure it? Passive can be very unclear and really inaccurate. So say hi, say yes to we and I. You can use it in your talks, you can use it in your writings. And this is one of the first papers by Einstein. He says in zwei Mitteilungen habe ich gezeigt, I have shown. So he's using I. And this is what scientists used to do a century ago. And unfortunately, I think there's been a tendency that's going away from that. And we're trying to sort of hide. We don't want to be seen there. And you can try, of course, with some grain of salt, but you can try to include some creativity, fun, and humor in your writing. And just a few examples. This was the title of the paper that we published in a Review of Modern Physics. This was the initial suggestion on the breakdown of the Born-Oppenheimer approximation for conical intersection of potentially energy surfaces of the same symmetry. Unless you work in the field, you really have no chance of understanding the title. This is the after title that we published, Diabolical Conical Intersection. It's still technical. You may not know what conical intersections are, but that adjective diabolical is great. It tells you everything you need to know. They are difficult to treat theoretically. They're diabolical, and it makes you want to read the paper. And as a matter of fact, this is a very well-written paper. It's been cited thousands of times. Other ways, sometimes there are these personal things that emerge. I have observed that the Hamiltonian philosophy is like avocado. You like it or you don't. So basically he's saying there is no good reason scientifically to choose one or the other. You like it or not, but they are equivalent. But that's a great way of saying it. And you immediately understand the message, and it's fun, it's lively. So we can insert these things in science. This paper is measuring the flux from a star, 1987A. The authors were saying their fluxes are changing on time scales that are shorter compared to the time scale of journal publications. So they're making fun of us and how long it takes for us to publish papers. And another example, this was a very complex paper. And he compares two different approaches to studying the problem to two ways of watching fish. In one approach, you stay fixed and you see the fish that's swimming by. In the second approach, you pick a fish and you follow it. What an effective way of explaining it. Really, I was struggling to understand what was the difference between the two approaches. When I read this, I immediately got it. So try to think about this everyday analogies. Even, you're speaking to somebody who doesn't know anything about physics. These comparisons are really key, and they may be useful even for people in the field. So always think about them. A note about figures. Figures are very important. Think carefully about them. A good tip when you're writing a paper is to, when it's ready, look at the figures independently, read the captions one after the other. Do they tell a clear story? And many people, I can tell you, many journalists, many funding agents, they read a paper, they just look at the figures, and if they get the story from the figures, they will maybe take time and go and look at the text too. So figures are a really important part of your paper. You have to allow people to read your paper by just looking at the figures. So prepare them carefully. And finally, the last concept I want to talk about, multiplicity. So I told you, you're not talking to your supervisor, but you and your competitors, but you are also talking to them. My message is that your paper can address many different types of people. So perhaps the first part, and the same applies to a talk, the introduction, the first part, can be appreciated by everybody, right? And then you go a little deeper. And maybe there's a part that only researching related fields can appreciate. And then you go deeper and deeper. Of course, you've done some really technical stuff. And then there's the core of your paper where researchers in the field will be able to understand it, but no one else. So you can allow your paper to talk to many different levels of people. You can allow your talk to talk about many different levels of people. And a comparison I often use is that of a hourglass. So your talk, your paper should be a hourglass structure. It's just all very broad. The first sentences, really everybody should understand it. And then it goes narrow. And when you're really describing your experiment, maybe there's only a few people getting it. And then you give the conclusions, and you have to remember to broaden it up again and start to telling people why they should care about what you've done. And this is really my final slide. And I'd like to make some more philosophical points related to everything that we've discussed today. So this is a hand-sketched memo from a very famous Italian writer. Italo Calvino is one of the most important writers in history, a fiction writer. And he is going to give a very important series of seminars at Harvard. They're called the Norton Lectures at Harvard. They're given by the most famous writers, musicians, thinkers. People like Herbie Hancock, for instance, gave it. Toni Morrison, the Nobel Prize for Literature. And he was going to talk about 6 values that a writer should have for the next millennium. And these are the values. And I think we can apply the same values to scientific communication, to writing, and also to speaking. The first is lightness. Try to be as light as possible. If you can say bird, do not say avian species. It has absolutely no value. The lighter, the better, always. Quickness. Your paper should be as short as possible in order to give the message that you want to give. Any additional word is not actually adding anything. It's distracting the reader, and it's compromising the accessibility of the paper. The third is exactitude. Your paper should have a flawless logical flow. Design that structure, that outline has to be perfect. The fourth is visibility. Figures are very important. Use them carefully. Fifth is multiplicity. Many people of different types will read your paper, will listen to your talk, will hear you speak. You can talk to many different people at the same time, to the most expert and to people who do not know anything. And different people will be able to access different parts of your talk, of your paper. And finally, consistency. So unfortunately, Calvino died on his way to Harvard. So we don't have a draft of his memo. We do for the others. But this is my interpretation about consistency. So recalling the message that I give you in the very beginning, as a scientist, as a physicist, somebody who's going to work using science and technology, you are a professional writer, you are a professional communicator. You have to take on this responsibility as an integral part of your profession. And if you do it consistently, so every time you give a talk, every time you speak to somebody about what you're doing, every time you're writing even an email, if you think about how you're doing this consistently, you think about, is this too complex or not? Do I know who the audience is? Can I picture myself who is listening to my talk? Can I picture myself who is receiving my email? Can I picture who is reading the paper? If I understand the audience and I relate to them, and if I try to do this every time that I'm doing this, without taking very long writing and communication workshops, just focusing your thoughts every time you're doing it a little bit, and you do it consistently, you will slowly get better. You will slowly recognize that your writing, your speaking will be a manifestation of you. It will be a manifestation of your passion for science. It will be a manifestation of the clear logical thoughts that you have in your mind when you're doing your research. So do it consistently, and slowly you will realize that you will see that your papers, you will see that your talks, they have your own voice. You will recognize yourself in what you're writing, in what you're saying. You will really find your own voice. And And this is really the most important thing, that people see you through your writing and through your communication. And I'll give you quickly 2 resources. This is a book that I recommend to everybody. It's called Writing Science: How to Write Papers That Get Cited and Proposals That Get Funded. It's really beautiful, quite philosophical. It's not very practical, but it is, I think, very consistent with the ideas that I presented today. And finally, one thing that we're doing at NYU, we give improvisation classes for scientists. So we work with actors, and we do interesting games where we ask young scientists to talk to each other in a strange way. Sometimes people are asked to explain their research, say on 5G cellular phone networks, to another person who plays the role of somebody who is traveling from the Middle Ages. So you have to play with them and make that information accessible to them. And I think this kind of classes are really nice because they develop your instinct for your audience. So when you're improvising with somebody, you have to connect with them. Maybe you have to explain your research to somebody who has, say, the hobby of fishing or the hobby of sailing, and you have to connect to their likes, to their personality. So there is something in improvisation that is very useful in, first of all, it's great for your speaking skills. You go out, you give a talk, and you can be much more natural. You can react to something and improvise. But I think the most important thing that it leaves you is an empathy for the audience. And that's really an important legacy. So I'm saying this because maybe at some point you will see this kind of workshop somewhere, conferences, or maybe you can encourage your departments to organize it. And if you want any suggestions, a lot of people are doing this online. It's not actually very expensive, with a couple of $100. Maybe your supervisor can finance you for taking this. Alan Alda Center is a very good place. Alan Alda is an actor from Hollywood. He worked a lot with Woody Allen, and he's developing this curriculum. And they are offering classes online too. So that's maybe a great resource. So with this, I'd like to finish. Thank you very much. I'm really thrilled to be here. This is my email. Feel free to reach out with any question, and let me know if you have any questions here right now. Yeah, good luck with the competition. And I'm really curious to see if I could solve the same problems that you're solving today. Probably not, but I'm not going to tell you. So thank you, and I'm open for any questions that you might have now.
Well, thank you so much, Matteo. I think that was a really brilliant presentation. In fact, I think I'm taking some lessons myself, because I do tend to write really long sentences and use a lot of adverbs. So I think you've given me a lot to think about. But I'm going to just check the chat here. So there was a question closer to the beginning of the presentation, which was a general question: how do we improve communication? But Abhishek, the person that posted the question, about 24 minutes later said the whole talk was based on my question. So I think
yes,
essentially.
Well, maybe I can add something.
Yeah.
I think really, we learn everything by copying, right? So I think really the most important thing you can do is to think about the things that you see that are communicated well. You read a paper, you think it's good, you understood it. So try it, ask yourself, why is it good? What have they done? What words are they using? You hear a talk and you understand it and you find it engaging and motivating. So what elements do they use? How did they start? How did they wrap up the talk? So try to have your antennas up and be receptive. And when you see good example, trust your instincts, because a lot of times I used to think, oh, this paper is too hard for me, I'm so stupid. But no, almost always they just didn't write it nicely enough. They might be famous scientists, but they're bad communicators. So trust your instincts. When you find something and you think you understand it, there's a good reason to believe that they've done a good job. And so try to learn from them. So try to be receptive and follow good examples.
Thank you very much, Matteo. I think that's a wonderful lesson to take from this. So I'm just checking here. Yeah, so there was a mention about sharing the PowerPoint presentation. So this is being recorded for you to potentially watch it again
Sure.
at your time, if you wish. So in principle, you'll be able to check out the presentation again.
Somebody was asking about the link. Maybe I will share it in the chat right now. I think it was the link to the writing a better scientific article paper. So I'm sharing it now, but you'll find it in the slides, and also write to me. I'm gonna write my email again in case. I know that when you close the Zoom presentation, you lose the chat. So take notes now if you want to keep it.
Yeah, brilliant. Thank you very much, Matteo. Yeah, so the next question also from Abhishek. I don't know if Abhishek wants to say the question, so I can allow unmute here. Abhishek, if you're there, if you want to.
Yeah.
Yeah.
Can you hear me?
Yes.
I wanted to ask about who is your favorite book writer, like physics textbook or mathematics textbook.
So you're talking about a textbook really about a physics course, or a sort of a
Physics course.
Well, I have to say all the
like Griffiths.
Yeah, they were in Italian or German, because that's when I studied. So I don't know if I can give you any useful textbook. I can tell you I really like Feynman's lectures, because they are, so that of course is English, and I think you can probably find them for free if you look hard enough on the web.
Yeah, they're available on Caltech's website.
Yeah, so I like them because they're not just clear, but they also give you the passion and the so it's not just their equations. They excite you about the topics, and I think that's a great asset. And also, I really like, if we're talking about broader, like science communication books, really almost journalism. I really like a writer. His name, I think, is originally from India, Simon Singh. He wrote beautiful books about the Big Bang, about alternative medicines, about cryptography. Many things. Is a great example of a physicist who became a science writer and is writing best-selling books. I definitely recommend you guys read this guy.
Thank you.
Thank you very much, Abhishek. Thank you, Matteo. So there is a question from Franca. Franca, if you want to ask it directly.
Yes, so I was wondering if you, like most scientific journals have a pretty strict restriction on how long articles can be, or they're supposed to be short, so that there's more articles that can be fitted in one edition. Do you think that makes the problem of bad writing worse, because people are worried they don't have the space to spend on explaining why and giving the context?
Well, no, actually, I would argue that it is the opposite. It's true that sometimes, because all people care about is telling people what they did, and they want to describe the details of their experiments. So sometimes when they have this word limit, their reaction is to sacrifice the motivation and the implications sections, which are very important. But I actually do think that words limit are very important because they have to they force you to focus really on your message. And if you just give an unlimited space, people will write these super long papers where it's they add all kinds of details, and the story is actually less clear, not more clear, because you're adding more information. So I do think that in general, this length limits, like many journals have a limit of 3 or 4 pages. Certainly Nature and Science cannot be too long. Physical Review Letters cannot be too long. I think if authors address the communication properly, which is they do not sacrifice the most important parts of the paper, which are the introduction and conclusions, at the expenses of the details, I think these limits are very important, and they make for better papers. And one thing that I really want to stress again is that there are so many things when you read the paper, so many things that you realize that you delete them and the paper will not change in its content. It will still deliver the same message. So many sentences that are very long, it could be shortened to half of the length. So many details about little experimental things that may not be necessary. Some journals allow you to put them in a method section or in another section, or maybe to add notes. I would say people would have really to make an effort to understand what they can sacrifice. And I think it should be really guiding. What I do when I write, at the end of everything, you have your paper done, you think it's okay, you think all the data you need to have there are there. You go a final time through the paper with the only focus on things that you can cut. And your goal is to make a paper at least 10% shorter. And so you have to come up with creative ways of shortening your paper. You have to look, every word you ask yourself, does it really need to be there? This adverb doesn't need to be there. You go through this, you try to reach a goal. Sometimes it might not be possible. Sometimes instead of reducing by 10%, you reduce by 20%. And I think your paper will gain a lot by really sharpening the message and really giving only the elements that are really necessary to the story. And I cannot emphasize enough, anything that you add is not more information that you are adding and helping the reader with. If that information is not necessary, it is detrimental to the message that you're leaving to the reader. So I think in general, these limits are very important. So I would not be in favor of removing them. But of course, they don't have to lead authors to just sacrifice the more accessible parts of their paper.
Thank you very much, Franca, and thank you, Matteo. So at the moment, I don't see more questions. So I think I would just like to, if you don't mind, Matteo, I would like to ask you a question myself, but I will leave that for after the question that Christian Palma just posted in the chat. Christian, if you want to unmute yourself to ask the question directly.
Christian? Oh, you can't use that.
Yeah, no worries.
Sure. Well, I think there are many shortcomings in the peer review process, but some people compare it to democracy. Some people say democracy is the worst form of government, except all other forms that have been tried before. So it's hard to imagine that anything will replace the peer review process. It really seems to be essential. I think it's key. If you're looking today, all the misinformation that's out there on social media, if we just leave information free to roam, if we don't have that filter where expert people weigh in on the results, I think it's hard to imagine that it can be replaced. A lot of people are, For instance, they are talking at some point, they were talking about the archive or open publishing. You just post a paper there, and then the community will decide. They will comment on it. We don't need referee. We don't need scientific journalists. The problem is that, if everybody is free to comment on those, and, maybe some papers go viral, you get comments from everybody, you don't know what the backgrounds are. I think it's really hard to imagine how to get rid of the system. But I think we can think of better ways of improving the system. One thing that I think it's quite important is what they call double-blind review. So right now, people receive a paper, the referees, and they know who has written the paper. And they may think, oh, this guy is working in a small country, not very famous, his lab, and maybe this result is not as big. If they receive a paper from the MIT or from Oxford and Cambridge, they think, oh, this must be good guys. So I think there is a bias there. There might be a bias about even gender, about where you come from, about even your race. I think many publishers are experimenting with double blind. I personally do think that we should use it always. It may not be easy. Sometimes it's hard to hide who you are because you're citing prior works and stuff like this. But certainly that's an improvement worth considering. As you're writing also a more interactive way, I think this is something that will be included. You have a paper out there, there can be comments after the paper, there can be other things, that assess what has been discussed in the paper. Maybe you don't realize there's a mistake in the paper, and so people can weigh in. So it can be more interactive, it can be improved. But I think the core of the peer review philosophy, I think it would be hard to think that that it can be replaced.
Thank you very much to Matteo and to Christian. There's another question here. How do you keep track of the thousands of papers you read?
Yes, it's a very good question, Marifa. I think some days I'm losing my mind. I feel like I have one of these old age diseases, and I forget I forget names. There is a lot of information that's coming, but I have to say, I mean, I don't keep tracks of all of them, of course. But I can tell you that papers who are written in a nice way, they leave a trace in you, they leave a fingerprint, they leave something that stays in you for a very long time. And I can still remember papers that I've read 10 years ago, just because they were explaining well, they were telling a good story. I was entertained as well as intrigued from a scientific point of view. And so I think if you write a paper well, any paper can leave a legacy in you. And of course, you cannot possibly remember thousands of papers, but the messages that you get from them, they stay with you for a long time.
Thank you very much for the question, Arifa, and apologies for forgetting to ask you to unmute yourself. So I would maybe just ask the question I have now. And I would suggest that if there are any additional questions, please post them soon. So we're a bit already stretched out of the time of the session, but because we have some flexibility and because Matteo has been so kind as to remain here to answer the questions. Yeah, maybe I would just ask you now. So I found it really interesting, the reference that you had of Einstein's article where he basically uses the I instead of the current usual way of writing, more impersonal way. So I did want to ask you if you think that there may be any chance of that more personal way of writing returning, and if you think that just that fact could have a good impact in terms of I don't know, maybe scientists projecting their own value more to the general public, or some consequence like that.
Yeah, I think, I mean, we have to make it happen. So it's also one of the reasons I'm giving seminars like this, because I hope that, you know, young people like you will go on and think about communication and find new ways of writing, and maybe some of these ideas can inspire you. I do think that, I don't know, maybe it's the social media world. I don't know. It really brings us, maybe it's a little bit narcissistic, but people talk more about themselves than they used to do 10 or 20 years ago. And I do think that the new generations are simply better in terms of communication. Some of the worst communicators, I think, are this sort of old professor who've been sitting there. They don't care really about their careers are settled. They don't care about, one of the writers that I quoted, one of the citations they had, if you went on looking, he was talking about shortcomings in communication and technical jargon. Says usually this defect, these problems are more pronounced or more frequent in they scale inversely with the hierarchy of your position. So the higher you up, the more important your professor level is, the worse you communicate. So I think there is a little bit of that, and I think it's very true. But yes, I think, you know, communication way is not something you can enforce. It will have to be developed by the community. And so, yeah, I hope that we can all think and work together so it becomes more. I think ultimately it's about, you know, going back to the example I gave at the beginning of the talk. I go to a cool party in Berlin and people think, oh, he's a nerdy physicist, I don't want to talk to him. And I think really this is a big problem. Like, we are asking the society to give us millions and billions to fund our research, to have careers, and we're doing something that's really beautiful, and it can be simple, it can be communicated, and we have to make sure that they get that we are doing something beautiful, something worthwhile, and in our daily interactions. Now, let's forget about writing science and nature papers. Let's forget about giving talks at a conference. But we go to a bar and we meet a random person. We talk about our research. We have to present physics with the beauty of physics. And I think that is something that we really have to work on.
Thank you very much, Matteo. And I see in the chat that Thara and Zoe were also told that writing in I was viewed as unprofessional. So they found it interesting that you mentioned that
Yes.
that perspective. I don't see any further questions at this
Yes,
point.
I can comment on that. I know that many people don't like using the active voice. I was just in a session a couple of weeks ago with a nature editor, and we were of the same opinion. Like, passive can be really ambiguous. It's not just the passive form, but it is ambiguous. You really don't know sometimes who did the action, and that's really a problem. It's inaccurate because it can mislead the reader. Maybe it's prior work, maybe it's not your work. So I think, I mean, I can understand you, and of course, like everything I said in my talk, these are sort of general ideas, and you may find that your supervisor wants to do things differently. You may find that you want to do things differently. And of course, passive can also be used for variety. There are situations where passive is better than active. Not very often, but there are. So you need a little bit to adapt. But I think in general, I would say it is time to start challenging these assumptions. And many old school people think we have to be impersonal. I don't think it's the case. I think we can start adding a little bit of personality into our writing.
Thank you very much. I see Abhishek says that Leonard Susskind also stressed on this point of writing better scientific papers in one of his seminars by saying people are stealing the soul of science.
Okay, well, in what way are they stealing the soul of science? They are taking away the soul, so they're taking away the emotions. Is that what he was referring to, Abhishek? Maybe he cannot.
Yeah, go ahead, Abhishek.
Maybe you cannot speak anymore. James, I recommend you take a look at the review of modern physics. So James is asking, is there something I can show my supervisor to convince him that we can use active? So I would point you at the review of modern physics article. So I imagine your supervisor is a physicist. And that article has a special section on using passive versus active voice. And Review of Modern Physics is the highest impact factor journal in physics in the world. So if he sees it coming from that source, maybe he will pay attention to it.
Okay, thank you very much, James, and thank you, Matteo.
And Rodrigo, sorry, Duarte, can I ask a question?
Yeah,
I was curious to learn. Everybody who asks questions, where they're from and what's the universities, just to have a feeling of where you guys are coming from.
Yeah, I think if whoever is okay, you have permissions to turn on your cameras and to unmute yourselves. Or
even you know, anyone who is not asking questions. Like I'd be curious to hear where you're from very quickly. And
Singapore.
Singapore. Thank you. Anyone else?
Oh, hi. I'm from Dominican Republic. I think you were in my warming up group the other day.
Yes, I was. I remember Dominican Republic. Of course. I've been there a few times.
Yeah, so we see in the chat some people from Ecuador, Germany, India, England. It's a nice geographic spread we have here.
I was curious because you said that you speak Spanish. So where are you from?
I am from Italy, but well, before starting physics, I was actually trying to become a musician. So I studied in Granada in Spain. So I had to learn the language. And it was, and then here in New York, I speak much more Spanish than English. So it keeps being trained by, I have a strange accent. People from, you probably would think I'm Argentinian from the accent.
Yeah, but I think just now you mentioned the like musician, right? Maybe you can like perhaps work on like group theory, the group theory and its effect and its analysis of music, and which is also applicable in physics.
Yes, this is a very interesting connection. You know, music is about mathematics a lot. Some people are inspired by mathematics and compose music. Some people have certain mathematical patterns in their mind when they're composing. I actually wrote an article about a scientist in Texas who is he's taking data on materials like superconductors and topological insulators, if you've heard of them, and he's translating these materials into musical compositions and see what happens. And he uses that composition scientifically, because from the music they produce, he can understand if a material will have similar properties to another material. Oh, some people have seen some of my classical guitar performance. Oh gosh.
Yeah,
maybe I should, because I I don't know if this will be good or bad for my career.
I saw some on Instagram. Really nice.
Okay, thank you. There was another question from Zoe. Is it important to come up with a compelling story to communicate our work? But how about those stories that overemphasize the research so the real work may not be that original? Yes, I understand. Of course, you know, not every story can be compelling. You know, you're not discovering the helical structure of DNA every time. You're not discovering gravitational waves every time. And most science is just a little step that improves. You're standing on the shoulder of giants and doing something new. And I think this is actually really crucial that you are clear about that when you're writing your paper. So I'm not saying writing a compelling story because you have to convince the reader you've done something extremely important. You've done what you've done, and you know what the importance of what you've done is. So a compelling story in the sense, like the narrative has to be compelling, and it has to communicate very clearly what was known before and what has contributed to it. And, you know, maybe a reader just gets the abstract, reads the intro and says, okay, this is not a big step, I'll stop reading here. That's also a possibility. But I think it's certainly better than hiding it and not saying it. So obviously you don't have to hype. But I would say hyping is not the common, I would say almost the opposite. Most people play down the result. They don't talk enough about the implications of their work, but some of them do. Some of them hype their results. So I think it's really important. I think what I wanted to say with telling your story is really to tell that additional new step, that one thing that makes your paper different from anything else. And it has to be very, very clear from your writing. So you're not cheating. You're not making people believe that you've done more than what you did. And so there is a subtle difference. I mean, you want to talk about the implications, but sometimes the implications are not that big. So you just got to be honest and say, you know, this is what we've done, and this is realistically what can happen. Maybe you can just suggest, you know, we've done this and we couldn't do more, but future research will explore these directions. But be honest about this. And I actually have a funny anecdote of somebody who was hyping their research. It was research on quantum physics, and they were talking about teleportation. And he was giving a seminar to young students. He was a tough Russian, He was a science studying quantum mechanics. He was talking about teleportation in a way that made you think that we can really teleport a human being from London to New York. And it was obviously hyping. It was obviously not accurate. It was not, if you paid attention to it, it was not really saying it, but many people who are not experienced, they could have thought that was possible. And so this big Russian scientist, he came from Bell Labs. These are really tough people. They are really used to be very aggressive if they don't agree with you. He stood up and then he said, there are very young people here, and you're making them understand things that are not really true. You're suggesting things that are not really true. This is actually porno physics, he said. This is porno physics. Young people shouldn't be allowed to see it. So I think there is a boundary, like when you are doing porno physics, when you're making people believe things that are not really possible, that are not really true. And I think it's something you have to be careful about. But that's also the thing. Good communication is really good in convincing people that you've done that specific thing, and that is the one thing that you want to communicate.
There's another small question there. Yeah. How will scientific journals that use literary styles impress the target audience?
I'm not sure I understand the question, Chan. You're saying the style that journals suggest, it's not compatible with impressing the audience, or
It's something to do if you write a scientific journal and then you make use of some literature like romantic, for example, and use it in the scientific journal, which has a lot of technicalities in it.
yes. Well, I think it's a subtle balance. Of course, you know, you can't write poetry, you know, in the entire paper. There is only so much that you could do. But I do think that there is a space for adding a little bit of livelihood, a little bit of action, a little bit of emotions in your papers. And I think this is really a skillful thing that you have to try to work on, how to include it in a way that doesn't sound, because I've seen people trying to do this and it doesn't really work. They're trying to be funny and it's not funny. It's something it's an experiment, I would say, something that you can play with and see how it comes across, how it's perceived. And sometimes you just see it on paper, like the avocado story, you either like it or not. And you just feel, oh, this is right. This is how it should be. It cannot be clearer than this. Also, I want to comment on your wording. You saying impressing the target audience, and this is something that I want to emphasize related to my point. We are not communicating to impress. We are communicating to be clear and to convey the message. We're not really, we should stop trying to impress, trying to be evaluated. We don't want to impress. We want to just leave a clear message. So everything that you do, every technique, maybe a fun experiment, maybe an unconventional way that serves that purpose, that is clear and really serves the purpose of communicating the message that you want to communicate, is going to be useful. So I think it's more an attitude.
Thank you very much for the question, Chan, and thank you, Matteo, for answering. So not seeing anything else at the moment. I would maybe suggest, unless Matteo, you'd like to go on for some more time, I would maybe suggest that we end the session now.
Sure.
Yeah. So I really want to thank you again for the brilliant presentation and for answering all of the questions, the good questions that the attendees of this session presented here. So I would just like to also have a final reminder that in about 1 hour and 20 minutes, so at 7 p.m. Portuguese time, we're going to have another guest lecture with Professor Dan Baker. So I'd like to ask everybody who can to attend that session, and finish just by thanking Matteo one more time for being available and for doing this wonderful workshop. I think, as we have spoken before, there's a good chance that we may have some more collaborations in the future.
That sounds great. Yeah. Thank you everybody for being here. I see a comment. Oh, Christian. Oh no, that was a direct message to me. Muchas gracias, Christian. Sí, conozco a Jorge Drexler y es uno de mis cantantes preferidos y compositores, y le sigo en Instagram y me gusta muchísimo su música. Okay. All right. Great. Thank you, everybody, and I hope to see you. I'll be around in coffee break rooms and stuff like this, and maybe I'll see you again.
Thank you very much.
Okay. Have a great day. Good luck, and I'm looking forward to trying your problems. Okay. Goodbye. Take care.
Bye. Take care, Matteo.